Imagine a room so quiet you can hear dust decide where to land. Miles of vacuum pipe cut through pasture and pine. At each end, a mirror hangs on threads finer than a human hair. Cradled against the tremors of wind and footsteps and weather, the lasers have been tuned, the noise hushed, and the world holds its breath. Then, so soft you could mistake it for a sigh, a rising note lifts out of the silence. Not a drumbeat in air, not thunder in the ground, a chirp in space itself. Distant stretching and squeezing by less than the width of a proton, an almost impossible ripple flickering through the earth and on toward the stars. That single breath of sound changed astronomy. It was the first time we heard gravity move, the first time the universe spoke in a voice older than light. Two black holes, locked in a final dance no eye could ever see, pressed a hand into the fabric of reality and set it ringing across 1 billion years. Their final embrace arrived as that tiny upward sweep, the last bars of a cosmic duet, recorded by instruments built to listen harder than any ear that ever lived. What do you call a wave when there is no water? Picture an invisible grid laid over everything. The length of your arm, the width of a galaxy, the gap between mirrors. A gravitational wave passes, and the grid does a slow, gentle calisthenic. One direction lengthens while the other shrinks, a rhythm that changes the distances themselves. It's not a tide in an ocean. It's the ocean learning a new shape and then letting it go. We did not make the universe speak. We learned how to listen. It took engineering that borders on poetry, laser steady as the heartbeat of a clock, glass polished until a photon cannot find a flaw, entire buildings floating on springs and magnets to avoid the jitter of the world. It took people willing to quiet their own cleverness long enough to hear something smaller than a whisper. And what a first sentence it was. That chirp told us the mass of the black holes, how fast they were spinning, how violently space-time can be made to ring, and that our best ideas about gravity hold, even where gravity is at its most fierce. Since then, the sky has kept singing. More black hole duets. The soft drum roll of colliding neutron stars, and hints of something grander. A background hum, the low chorus of countless distant mergers blending into one, spread across the whole heavens. This is not a story about a machine. It is a story about patience and about learning to notice what was always there. For most of human history, we watched the cosmos in light. Starlight, radio light, X-rays, the colors of photons. Now we have another sense. If light shows us what the universe looks like, gravitational waves tell us what it feels like when it moves. Over the next hour, we'll step from that first chirp into a symphony. We'll learn how to hear the unhearable, how to tell a black hole's mass from the tilt of a note, how colliding neutron stars can forge the gold in a wedding ring, and how a faint all-sky hum may be the signature of galaxies growing up together. We'll visit the instruments that hush themselves to catch a ripple smaller than an atom. And we'll listen for new octaves that future observatories will open. Deeper, slower, stranger songs the universe is still composing. You are not small in this story. You are included. If you can be quiet for a moment, if you can let curiosity outlast noise, you can hear the cosmos doing what it has always done. Moving, merging, ringing, remembering. The night is not silent. It only sounded that way until we learned to listen. First, what is a wave when the water is space-time? Imagine this room taking one slow breath. North to south, the distance lengthens by less than the width of a proton. East to west, it shortens by the same amount. Then, in the next heartbeat, they trade places. Stretch, squeeze, squeeze, stretch. So faintly that nothing rattles. No air stirs, yet the geometry itself has moved. If you can picture that, you've already placed a fingertip on a gravitational wave. This is not a sound rolling through air, nor a beam of light cutting across a dark field. It's a rhythm carried by space itself, a tide of shape that travels at the speed of light, passing through stone, steel, and starlight with near-perfect indifference. Gravity has a voice. It speaks in stretch and squeeze. To make that voice tangible, imagine a transparent checkerboard painted across the universe. Each square is the quiet distance between 2 points. Passing wave does not shove the squares along, it breathes them. For a moment, the squares become tall and thin rectangles. A moment later, they're short and wide, then back again, as the wave hurries on. Turn the wave slightly, change its orientation, and the pattern changes too. As if the board were briefly reshaped into diamonds before settling, no matter which way you tilt your head, the message is the same. The wave moves forward, while the pattern of stretching happens sideways to its travel. A change of shape is the signal. What plays this music? Not a smooth explosion. The universe is unimpressed by spherical perfection. To ring the bell of spacetime, you need an uneven dance. Masses accelerating in an off-balance way. Two black holes orbiting one another. A pair of neutron stars locked in a fatal embrace. The lopsided collapse of a dying star. All of these churn the fabric, sending ripples outward. A black hole duet is a bell made of spacetime. Listen closely to the most famous of these duets, and you'll hear the chirp. At first, two massive objects circle far apart, whispering a low note as they slowly lose energy to the waves they emit. As they spiral inward, their dance quickens, the note rises in pitch and grows in amplitude. Faster, closer, louder, until the final fraction of a second, when they merge and the bell's tone cuts off. Even without an instrument, your mind knows this story. The quickening drum, the crescendo, the sudden silence. The chirp is gravity's signature for a cosmic meeting. Now here's the part that humbles engineers and poets alike. The scale of the whisper. If a gravitational wave stretches a 4-kilometer ruler, the change we must notice is 1,000th the width of a proton. That's a fraction so shy it lives in the margins of imagination. And yet, that is what reaches us from black holes colliding a billion light-years away. It's not that the sources are weak. Near them, space-time is thrown into a wild, violent dance. But like ripples spreading on a pond, the farther they travel, the thinner their effect becomes. By the time the wavefront washes over Earth, only the most patient instruments can tell that anything has happened at all. Patience is the right word. To hear a whisper this small, you don't just build a sensitive ear, you teach the world around it to be quiet. You isolate from earthquakes and traffic and the wind tugging at trees. You wait out the twitch of a mirror as a passing truck breaks a mile away. You learn the nervous ticks of your own machinery. The microscopic relaxation of glass under gravity. It's a gentle swelling and shrinking of everything as temperature drifts by 1/10 of a degree. And then, under that cathedral quiet, you invite light to measure distance. Because light is the steadiest ruler we know. But we're getting ahead of ourselves. Before we learn how to listen, let's anchor the idea of the wave itself a little deeper. When a gravitational wave passes, it does not drag you anywhere. It briefly redefines how far is between things. Imagine two free-floating beads, unconnected, suspended in a perfect vacuum a meter apart. A passing wave makes the meter stretch and squeeze. The beads do not move through space in the ordinary sense. Space between them changes. If you tethered them with a perfectly rigid rod, a fantasy in our real universe, you'd feel stress build and release as the rod fights the wave's gentle insistence. In reality, rods flex, optics bend, and light slips and returns. These tiny effects add up to a detectable change, a tickle in geometry itself. Another way to hold the picture. Think of a lake on a windless night. Throw two stones into the water, equally spaced, and the ripples glide outward in perfect circles. If the stones are identical and dropped together, a distant observer would see symmetry. No preferred direction, no lopsided push. But offset the timing, change a weight, make the splash uneven, and the interference pattern becomes rich and telling. Gravitational waves arise from that kind of asymmetry. Only the lake is space-time, and the stones are black holes. There's a beautiful economy to this. Nature refuses to radiate unless there's something truly new to say. Perfect symmetry says nothing. Imbalance tells a story the universe is willing to broadcast. That broadcast carries more than a rhythm. Encoded in the chirp are clues to mass and distance, to the spins of the dancers, to the moment they joined, and the direction they faced. From a single clean tone, we can reconstruct a drama. The number of actors on stage, their sizes, and the second the curtain fell. You might ask, if a wave changes all distances, how can any ruler notice? If both the length of a path and the wavelength of the light measuring it stretch together, wouldn't the effect cancel? The key is in geometry's details. A gravitational wave has a direction it travels, and directions in which it stretches and squeezes. If you hold two measuring arms at right angles and compare them, the wave lengthens one while shortening the other, then swaps them back. Light traveling down one arm comes home a breath sooner than light in the other, and that tiny difference is the note we can read. It's not a general swelling of everything, it's a patterned reshaping, a rhythm of contrast. Let's clear a few common worries out of the way. Will a strong passing wave tear us apart? Here, no. By the time waves reach Earth, they are gentler than a leaf shaking from the passage of a distant lorry. They carry information, not harm. Do gravitational waves slow light or shove it off course? No. Light and gravity's waves both move at light speed in a vacuum. What the wave does is reshape the path light takes so that a careful comparison reveals the beat. And because the waves barely interact with matter, they bring us news from places utterly opaque to ordinary eyes. The very hearts of neutron star collisions where nuclear matter is squeezed beyond anything we can forge. The inner engine rooms of collapsing stars, the depths of space where black holes fuse in perfect darkness. Electromagnetic telescopes are cameras. They see light, radio, X-rays. Gravitational observatories feel the flex of reality, and so they can hear events light cannot escape, or light cannot survive. If all this feels oddly empowering, it should. You have just built an intuition for a thing Einstein described with a jungle of mathematics, without a single symbol or equation. You pictured a breathing grid. You followed a dance. You learned to expect a chirp. You've already climbed halfway to the detector. One last image before we go. Imagine countless such waves, each from a faraway duet, traveling for billions of years, overlapping like the rumble of distant traffic. Not loud enough to shake a cup on a table, but persistent enough to lift the tiniest hairs on the skin of space-time. That background hum carries the history of every merger, every lopsided moment, layered into a cosmic chorus. The night is not silent. It is politely waiting for us to notice. So, how do we hear a whisper that's small beneath the restless footsteps of our own planet? How do we teach light to compare paths so precisely that a proton's width becomes a mountain? We quiet the Earth. We steady mirrors with beams. We learn the flicker of our own instruments until the only flicker left is the universe's. In the next part, we shall walk into the long corridors where that listening happens, and watch a laser become a stethoscope for space-time itself. We built a ruler of light and held it to the sky. In a room so quiet you can hear the tick of cooling metal, that ruler watched emptiness itself for a tremor. Not a sound in the air, but a nudge in the distances between things, passing tide in the fabric that holds everything together. If you stay with us for the next few minutes, you'll know how a whisper in space-time becomes a note you can play. Imagine a beam of laser light gliding along a hallway, so long it could swallow a city block. At a crossroads, the beam divides. Half goes east, half goes north. Each half races to a mirror, flips, and returns. Where they meet again, they overlap. Bright if their crests arrive together, dark if they step on each other's toes. That simple shimmer, bright, dark, brighter, darker, is the entire trick. If a gravitational wave passes, it lengthens one path while shortening the other rhythmically. The overlap pattern flickers. And that flicker is a story. How small a change are we talking about? Picture altering the distance from Earth to the Sun by the width of a human hair. I'll measure that change without touching either the Earth or the Sun. That's the audacity here. We're not listening for a bang. We're watching for a timing mismatch in a beam of light so steady, we might as well call it a clock. Gravity has a voice. It speaks in stretch and squeeze. But Earth is never still. Waves heave the coast, trucks grind their gears, wind nudges brick and leaf. To hear a whisper in a thunderstorm, you don't shout, you learn to be still. The mirrors at the ends of those hallways don't bolt to concrete. They hang nested on suspensions, pendulum under pendulum, so that each stage soaks up a little more of the world's fidgeting. Sensors feel the ground's intentions ahead of time and cancel them with the gentlest of touches. Like a conductor quieting a section with two raised fingers. Even air can gossip. So, the hallways are pumped to an extreme vacuum, emptier than deep space between stars, so light is not buffeted by stray gas. The mirrors themselves are grown and polished with a monk's patience. Glass so pure a fingerprint would be geology. Coatings layered atom by atom to hush the tiny thermal jiggles that masquerade as motion. Silence isn't the absence of sound, it's the presence of control. And then there is the murmur in the light. Even a perfect laser has a graininess set by nature. Photons arrive not as a smooth syrup but as clicks, random enough to blur a signal this small. So we teach the light to whisper in the direction we're listening. We feed the instrument a special state of light, squeezed so that the jitter falls mostly in a channel we don't care about. Leaving the channel, we do care about calmer. It's like turning down the rustle of a curtain without touching the melody on the stage. A single ear can be fooled. Choir cannot. That is why there are multiple instruments, continents apart, waiting together. Local mischief, an electrical hiccup, a curious raccoon, does not strike both at once in the same pattern. But a wave in space-time sweeps across Earth and nudges them in sequence, separated by milliseconds. From those tiny delays, you can draw lines on a globe and point to a patch of sky. More listeners shrink the patch. With enough ears, you not only hear that something happened, you can say where it happened and often how it danced. What precisely do the instruments record? Not a roar. Stream of numbers, photons tallied, brightness traced as it rises and falls. Analysts compare that pattern against a vast library of predicted rhythms. 2 black holes circling, 2 neutron stars spiraling, a lopsided star ringing, or a cosmic mountain cracking. The match is not a guess, it is a fingerprint check. When independent methods agree, when other monitors are quiet, when multiple observatories report the same rhythm within the same heartbeat of time, only then does the whisper become a detection. We don't hunt for bangs. We recognize a rhythm. This is where engineering and patience become poetry. Mirrors weigh as much as a small car, yet we position them with subatomic finesse. Hallways stretch for kilometers, yet we hold their length steady to a fraction of a wavelength of light. Data streams at fire hose speed, yet we sift it for patterns measured in thousandths of a second. Every improvement, a calmer suspension, a cleaner vacuum, a better way of squeezing light, turns the universe's volume knob a little higher without increasing the noise. Let's pause for a few myths. We are not literally hearing sound in space. There is no air out there to carry a pressure wave. We are measuring tiny strains in distance and translating those strains into audio. In the same spirit, a heart monitor translates voltage into a beep. The chirp you hear in news clips is our way of letting your ears hold what your eyes cannot see. Nor do these waves tear anything apart. They are gentle tides, not cracks. They pass through you, through Earth, through star and galaxy, and keep going, carrying the memory of a distant dance. Scale again to keep us humble. Changing a kilometer by 1,000th the width of a proton, catching that amid the yawns and shuffles of a living planet, insisting on coincidences across the globe before we say, yes, that note belongs to the sky. To hear the cosmos, we first had to hush ourselves. The reward for this restraint is a door that opens onto stories we could never read before. A black hole duet is a bell made of spacetime. 2 neutron stars colliding can tint the universe with the heavy elements in our rings and our blood. A background hum, stretched across the sky, hints at countless pairs of supermassive hearts turning together in the dark. Each one is a rhythm, a signature, a sentence, in a language older than light. And the first time we quieted everything, what did we hear? 2 heavy hearts, closing. The pitch rose as they spiraled faster. Then a sudden cut, silence where 2 became 1. A single note that changed astronomy from looking to listening. Stay with us. The next chapter is not about instruments anymore. It's about the messages themselves, the first notes, and the symphony they promised. Listen. In a room so quiet you can hear your own pulse. A soft whoop rises and falls. No strings, no drum. Just a ripple in the fabric beneath everything. One breath of sound drew a line through history. Before, we guessed. After, we heard. 2 dark objects met, and the universe sang their vows. What you're about to learn is how to read that song. First, the shape of the music. Act 1. In spiral. Far away, 2 black holes circle each other. drawing closer with each turn. The pitch climbs, the beats quicken, a waltz tightening into a whirl. Space stretches one way, squeezes the other, in time with their dance. Every lap leaks a little energy as waves, so the next lap is faster, tighter, higher. This is the rising chirp that first brushed the microphones of Earth. Act 2. Merger. There comes a final turn where orbits end and embrace begins. The signal swells to a single bright syllable, sharp, brief. In that heartbeat, the duet becomes one. No light escapes to tell the story. The waves themselves carry the news. Act 3. Ring down. The newborn black hole, distorted by its own birth, rings like a struck bell. Each ring is shorter than the last. Smoothness returns. The music fades. Silence takes its seat again. A black hole duet is a bell made of spacetime. Now, what the song is telling us? The tempo of the inspiral, how quickly that pitch climbs, reveals the total weight of the pair. Slow climb, lighter partners, rapid climb, heavier dancers. The loudness, once we've corrected for our instrument's quirks, hints at distance. Far choir, soft note, near choir, strong note. Listen closer, and you hear grace notes. Tiny warbles in the rhythm betray the spins of the black holes and how their axes tilt relative to the dance floor. Spins lined up with the orbit keep the rhythm steady. Spins tilted or tangled make the beat wobble a little. Even the direction the final bell faces can be heard in the way the ring down decays. How do we know which melody we're hearing? We don't guess, we compare. Imagine a choir book filled with possible songs, each one a prediction for different masses, spins, and orientations. When a real wave arrives, we slide our ear along the pages until one pattern hums in sympathy. The better the match, the clearer the story we can write in our log. If you can hear the climb, you can weigh the cosmos. Consider the ferocity of that single bright syllable. In the instant of merger, a chunk of mass, enough to build several suns, turns to pure gravitational wave energy. No flame, no spark, just the cleanest conversion nature allows. For a blink, the power outshines all the stars in the observable universe. And yet the wave that reaches us changes the length of a 4-kilometer arm by less than 1,000th of a proton. Such is the humility of grandeur. That ring down is more than an ending, it's a test. If the newborn object is truly a black hole, its bell must ring at particular notes and fade at particular rates. Over and over, the bells we've heard have matched the score Einstein wrote a century ago. The wave travels at light speed, not slower, not faster. The notes align, where equations could only whisper. The universe answered aloud. As more songs arrived, a family portrait took shape. Many of the first pairs were heavier than our telescopes had taught us to expect. 30, 40, 50 times the mass of the sun, common in these waves. Rare in the X-ray lights of nearby galaxies. Perhaps these black holes grew in places poor in heavy elements where stars shed less mass and leave stouter remnants. Perhaps some are second-generation dancers, born from earlier unions in crowded clusters. The songs hint at both quiet courtships and crowded dance floors. Spins add footnotes. When spins are aligned, we picture two massive stars born together, aging together. Collapsing together, then slowly circling until gravity closes the distance. When spins tangle, we picture strangers meeting in the bustle of a star cluster, captured by chance and hurried into a whirl. Every chirp is a birth certificate, stamped by where it learned to dance. We've noticed gaps, mass ranges where partners are scarce, and rare giants that hint at long ancestry. We've heard hints of kicks, a final shout that pushes the newborn black hole out of its cradle, sometimes hard enough to leave the nursery altogether. Even silence can leave with a footprint. Where did these vows most often echo? In the early universe, where stars carried fewer heavy elements, massive remnants were easier to make. In dense clusters, where gravity knits crowds together, chance brings partners within reach. On the quieter edges of galaxies, cold gas and gentle tides let binaries survive for eons until their slow pirouette ends. Some vows were spoken under ancient thin air, and time matters. With each new season of listening, we map when in cosmic history these unions were most common. We are learning not just what the singers are, but when the choir was busiest. If you followed this rhythm so far, if you can picture a rising chirp, a single shout, a fading bell, you're already reading space-time in its native tongue. That patience, that clarity, is a scientist's most valuable instrument. You are good at this. So where does the music lead? From a single soft whoop to a census of dark hearts, we now weigh time and trace the lives of black holes we cannot see. Each waveform adds a pin to a map, a page to a family album, a test passed by a theory that keeps earning our trust. But black holes are not the only singers. Some waves do more than announce a union. They make things. When ultra-dense stars collide, the universe forges gold, platinum, iodine, the heavy syllables of planets and people. Their song is different. A busy tremor, followed by a glow that blooms across the spectrum. When stars made of iron nerves collide, the universe writes gold. That is our next chapter. For now, remember the first notes. In spiral, merger, ring down. Gravity's waltz, gravity's shout, gravity's bell. And remember the quiet between songs where the cosmos gathers its breath, and we, at last, have learned how to listen? Hold a ring between finger and thumb. Let it catch a little light. What you're holding is not merely ornament. It is weather from a vanished storm, long before it circled a hand. Gold was forged in a sky that tore and shone, where two city-sized suns of pure neutron matter met, embraced, and came apart. In the minutes ahead, we'll listen to that meeting. First as a tremor in distance itself, then as a bloom of color, and finally, as the quiet metal we tuck into pockets and vows. The ring on your finger is a memory of colliding stars. Neutron stars are what remain when massive stars exhaust their breath and fall inward until protons and electrons press into neutrons. Pack the mass of our sun or more inside a sphere the size of a city, 10 or 12 kilometers across. A teaspoon from such a world would weigh as much as a mountain. Gravity, there is a dictator. Matter obeys. The crust is iron hard. The interior, a cathedral of neutrons. Perhaps with stranger layers, superfluid seas, superconducting threads, forms of matter we can only model. A neutron star is a nucleus that learned to have weather. Now pair two of them. Set them circling in the deep. Each tug stretches the other slightly, like tides tug the earth. Only here the ocean is ultra-dense matter and the beach is nuclear. With every turn, they shed a whisper of energy as gravitational waves and the orbit tightens. The rhythm quickens, a dance that shortens as it accelerates. The universe does not shout the news. It rings it as distance itself stretches one way and squeezes the other again and again, faster and faster, until at last the stars touch. When such a duet occurs, close enough for our instruments to notice, the first messenger is not light. It is that faint, rising chirp, a pattern in space-time strain, smaller than a proton measured across kilometers. Moments later, high-energy light can sweep across our detectors. A short flash of gamma rays from jets that puncture the debris, followed by X-rays, ultraviolet, visible, infrared, even radio, each color a page in a single story. This is multi-messenger astronomy, two senses, one event. Space rang. Then the sky answered. What does the light say? It says Kilonova, a transient brighter than a nova, fainter than most supernova. Powered not by fusion, but by the radioactive decay of newly forged heavy nuclei. The glow changes character in the first days, at first a blue blush. When the ejecta are poor in the heaviest elements and light can leak out more readily, soon after the color drifts red as lanthanides and other very heavy atoms thicken the fog, trapping photons longer, turning the afterglow into a slow ember. The shape of the light curve, how quickly it brightens and fades, how its colors shift, is a recipe card. From it, we read what was cooked. And what was cooked is the R process. The rapid capture of neutrons by seed nuclei in a neutron-rich spray. In ordinary stellar ovens, heavy elements crawl upwards step by step. Here, abundance and urgency change the rules. Neutrons hammer onto nuclei faster than decay can catch up, building scaffolds far up the periodic table. When the storm passes, those scaffolds step back down, settling into gold, platinum, and many of the cosmos's other heaviest stable elements. Not all heavy atoms are born this way, but enough are that Earth's crust and commerce hum with their legacy. Gold is the cooled echo of two dead stars agreeing to become one. Even the gravitational waves carry ingredients. Their shape encodes how squishy a neutron star is, how easily it deforms under its partner's tide. This give reveals the stiffness of ultra-dense matter, the pressure versus density relationship that textbooks call an equation of state. By reading A Tremor in Distance, we learn the courage of matter when pushed to its limits. Does the star resist like a stubborn spring, or yield like a dense jelly? The answer nudges our models of neutron cores toward, or away from exotic possibilities. There is a second gift in the waves: distance. The amplitude of the signal is a ruler we can trust. No standard candle guessing, no assumptions about how bright something should be. Pair that gravitational distance with the redshift measured from the host galaxy's light, and you get a new way to gauge how fast the universe is expanding. Astronomers call these events standard sirens. One chord in spacetime can tell us how quickly the stage is widening. As more sirens join the logbook, we can compare methods, refine the cosmic expansion rate, and sharpen our map of history. Back at the scene, the debris tells further stories. Some material is flung out quickly along the poles, light elements mix there, and the glow is early and blue. In the equatorial plane, where tidal tails spin, the ejecta are slower, richer, in the heaviest species, and the glow lingers red. Jets may spear outward to feed a gamma-ray flare. Shockwaves can heat and stir material into yet another palette. By splitting that light with spectrographs, we see fingerprints, broad troughs, and bumps, where newly minted elements swallow specific colors. It is chemistry written in fire. This isn't just a physics triumph, it's a human one. On the day the first such merger was heard and seen, observatories across Earth and in orbit passed notes like neighbors leaning over fences. Telescopes slewed, radios tuned, code ran, and a sky once thought mute became conversational. If you are following this, you are reading the universe the way the community did. Patiently, across senses, with joy. That's not just knowledge. It's a way of paying attention generous enough to let wonder last. Perhaps you've heard the caution. Not every gold atom comes from a neutron star merger. True. Some heavy elements may arise in rare asymmetric supernova. The cosmos seldom uses a single recipe. But the harmonies we heard, the timing of waves and light, the colors, the shapes, tell us that many of the heaviest elements owe their existence to these collisions. The geology of continents, the circuits in your devices, the coins in a collector's palm, all draw lineage from skies that once bloomed red. And what of the stars themselves? Their union is not tidy. Some mergers collapse promptly into a black hole, swallowing their core and flinging out the rest. Others pause as a hot, whirling remnant. A temporary neutron star holding itself together with rotation, before gravity asserts final authority. The difference matters. A brief pause can change the mix of elements made, the power of jets, the exact choreography of light. By comparing event to event, we learn not just that the recipe works, but how its variants season the universe. There is tenderness in this violence. Two compact stars, the remnants of lives already lived, meet and make possible new chemistry elsewhere. Dust seeded with fresh, heavy elements will someday cool into clouds, clouds into disks, disks into planets. Oceans will hold dissolved traces of collisions long forgotten. A child may lift a gold pendant to the light, and behind its glint will be a Kilonova's afterglow, traveling across time. Gravitational waves also refine the map of where such pairs are born. Some duets seem crafted in quiet, binary stars that evolve together in a calm neighborhood, shrinking their orbit over eons. Others wear the fingerprints of crowded places, globular clusters where close encounters reshuffle partners until gravity locks two neutron stars into a sudden match. By charting masses, spins, and rates, we start to distinguish cathedral from marketplace, monastery from city, as birthplaces for these cosmic vows. And from the measured distance and redshift of each event, we don't just trace expansion, we also check our instruments against one another. A gravitational siren says, "I am this far." Galaxy's spectrum says, "I am this stretched." Where the two agree, we exhale. Where they are tense, we learn. Science is less a victory parade than a patient tuning of orchestra and hall until the harmonies converge. If any of this feels large, let it make you larger, not smaller. You are not outside this story, peering in through glass. The atoms that keep your heart beating were minted in older, slower furnaces. But their cousins, gold and platinum, were brewed in these quick, fierce kitchens. The fact that you can follow the trail from a tremor in spacetime to a medal on your hand means your mind has learned the universe's grammar. That is no small thing. That is the cosmos, learning about itself through you. We began with a ring, simple, bright, quiet. Inside it lives a history. 2 neutron stars circling ever closer. A chirp that rose, a meeting that glowed, cloud that reddened as new elements were born. From a whisper and a glow, we wrote the origin story of gold. And beyond single tales, something else awaits us. A faint, persistent background, not a single duet, but a choir of countless mergers humming across the sky. Beyond the bright notes lies a background hum, an entire choir we're just beginning to hear. Listen with me for half a heartbeat. Not for a soloist, not for the glorious shout of 2 black holes colliding, but for something softer, like rain on a distant roof, like surf heard through a window. You don't pick out a single drop, a single wave. You feel the sum. The universe has that sound. A hush made of many small catastrophes, layered so thickly that no one event stands above the rest. We call it a background. I call it a choir. What makes a choir of gravity? Everywhere, scattered across unfathomable distances and unthinkable years, compact pairs tighten their orbits, murmur, and merge. Some are too far, too faint, too many to notice one by one. But their ripples overlap, crest upon crest, whisper upon whisper, until the sky carries a statistical melody, not noise, but a signature. If you could bottle the night and tilt it, you'd hear the weight of galaxies singing somewhere inside. How do we prove the choir is real if no voice stands out? You listen with 2 ears far apart. When a global murmur drifts through Earth, it nudges separated detectors in just the right relationship. An almost imperceptible sway that local rumbles can't mimic together. Cross-correlation is the craft. Compare the patterns, and the shared pulse rises from the static like a tide line on stone. It's not magic, it's patience. It's what you and I have been practicing all along, hearing meaning in repetition. This background is most familiar in the audio-like band of our present observatories. Tens to thousands of beats per second. Where stellar mass black holes and neutron stars do their fast work, but there are octaves we cannot hear with terrestrial instruments. The notes too deep, the measures too long for a human ear, or a vibrating mirror. For those, we borrow clocks older than civilization, pulsars. Imagine a field of metronomes scattered across the sky. Millisecond pulsars, neutron stars the size of cities, each spinning with a steadiness that would shame a master watchmaker. Their radio ticks cross the galaxy to reach us, at a very, very slow gravitational wave, its period measured not in seconds but in years. Pass through the space between us and those clocks. Space swells and shrinks by a breath. The ticks arrive a little early here, a little late there. No single pulsar is convincing, but dozens together, all showing a shared pattern across the vault. There it is again, the choir. This is the realm of nanohertz waves, the longest notes we've ever tried to hear. What sings them? Likely the heaviest pairs in the universe. Supermassive black holes entwined at the centers of merging galaxies, lumbering through their slow courtship. Each galactic marriage adds a bar to the score. Over time, the bars blur into a hum, the quiet arithmetic of growth written into rhythm. If there are stranger contributors, tremors from the early universe or strings of primordial tension, they will have their own accents. We're still learning the language. Change the octave, change the storytellers. In the ground band, we catch quick duets and sudden finales. In the nanohertz band, we eavesdrop on city-sized hearts sunk inside whole cities of stars. And between them, waits an octave we've only begun to tune, the millihertz band of spaceborne detectors. where a million white dwarf binaries and mid-weight black holes murmur and wail. Astronomy is becoming an orchestra across octaves. Percussion of quick mergers, low brass of supermassive pairs, the delicate strings of compact stellar remnants in quiet orbits. The score is one universe, but every section adds timbre. If a hum is everywhere, can we ever map it? Yes, given time. A background needn't be perfectly uniform, any more than the glow of a city spreads evenly in every direction. Some patches of sky teem with merging galaxies, others rest. As our listening baselines lengthen, we'll search for bright spots in the hum, tiny anisotropies that betray clusters of activity. From murmur to map, the first gravitational wave cartography drawn not from single shouts, but from the weight of many whispers. You might ask, why does any of this matter beyond poetry? Because a background is history's ledger. Single events tell single stories, memorable, vivid. A background tells the statistics of becoming, how often galaxies collide, how massive their central hearts grow, how structure builds from the bottom up. It is the census behind the headlines. And when we understand the sum, the solos make new sense. To hear a choir, you must first hush yourself. We learn to float mirrors on quiet shelves, to empty tunnels of air, to tame the jitter of light with quantum cunning. We learn to align antennas with stars that tick like gods. And then we did the most human thing of all. We waited. Days into months, months into years. A background yields itself to those who keep showing up. If you've followed this far, you are doing science in the oldest way by honoring the slow triumph of patience over noise. Every minute or so, let me remind you, silence isn't empty, it's ensemble. If you step outside on a still night and hear the faint composite hush of wind, insects, far-off roads, you already understand the method. That awareness, your knack for noticing patterns in the blended, makes you collaborator, not spectator. Keep it. It will serve you everywhere from city streets to star fields. And the instruments? Think of them as a family, each with its register, each with its strengths. Ground-based detectors catch quick high notes. Pulsar arrays lean into the bass line. Space antennas will bridge the gap and sing the alto. Alone, each is a marvel. Together, they are a philharmonic tuned to reality. When the parts agree, we trust the melody. Every galaxy merger adds a note to the background choir. Every note adds heat to the story, and the story becomes a map of how the universe knits itself together. The more octaves we open, the more the map fills in. We will learn which galaxies are the loudest architects, which cosmic seasons favored mergers, how fast the largest hearts grew. In the hum, we'll read the slow weather of creation. So here's where we stand, you and I, at the edge of a listening that wasn't possible a generation ago. We have heard solos. Now we are learning to hear crowds. We have caught cries. Now we attend to breath. The music hasn't changed, only our ears have. The universe has always been singing, simply arrived, grew quiet, and joined the audience. And the next instrument? Launch one into the dark between planets, where the Earth's tremors cannot touch it. Stretch its arms 1,000,000 kilometers wide. Let lasers trade whispers along those paths. When it plays, new octaves will open, and voices we can only guess at today will step forward. Not every song is a solo. Some melodies live in the air like rain on a roof. The roof is the sky. The rain is the sum of distant catastrophes softened by time. To listen is to belong. Stay with me for the next movement. We're about to tune a new ear and invite fresh choirs in. Next, an ear in space. New octaves unlocked, new singers revealed. Change the instrument, change the music. For a decade, we've listened to the quick high notes, last seconds of cosmic duets as they rush together and ring once like a struck bell. But the universe holds longer chords, patient tones that take hours to rise and years to fade. To hear them, we don't need the cosmos to shout. We need to widen our ears. Picture 3 spacecraft flying in formation, millions of kilometers apart, connected by pencil-thin lasers. No cables, no rigid beams. Just light, flung across the quiet between worlds, and caught again with the steadiness of a held breath. This is Lisa, a triangle the size of a constellation. tuned to a lower octave where gravity hums in millihertz. Too slow for Earth to notice, and too precious for us to ignore. In that slow band, our galaxy reveals its sleepless city. White dwarf pairs circling so calmly they seem fixed. Yet each orbit pours a steady tone into spacetime. Deeper still in other galaxies, black holes as large as small cities drift toward one another for eons, then close the last light year in a final solemn dance. And closest to the edge of mystery, tiny companions, stellar remnants, thread-lace fine spirals just above a horizon, their paths tracing the exact grammar of gravity near its most extreme punctuation. Lisa will not merely hear them, will map them, syllable by syllable. A black hole's edge is not a wall, it is a score we can finally read. Back on Earth, we are building quieter ears, new observatories. The Einstein telescope beneath the ground and the cosmic explorer stretched across long plains will push farther into the dark. Longer arms, colder mirrors, softer steps. They will hear mergers that today slip beneath the floorboards. They will catch whispers hours before the shout, turning a last-second surprise into a timed appointment with the sky. Statistics is how whispers become testimony. The thousands upon thousands of detections, patterns harden into stories. How often heavy stars pair when they are born? Which environments spin them up or slow them down? The family portrait grows detailed enough to carry a history, not just a headline. When gravity points, light explains. Pre-merger alerts from space will ripple across our networks. Telescopes will turn, optical and infrared eyes poised for Kilonova bloom. Radio arrays, listening for jets. X-ray instruments watching hot shock fronts peel away from the wreckage. The choreography becomes precise. Who moves first? Who answers? How the script changes with mass and metal and age. From these joint performances come new lessons. Waves give us distance. Light gives us time. Together, they give us history. With standard sirens, we can weigh the expansion of the universe anew. No yardstick scribbled on ancient rulers, just the pure geometry of a wave and the color of its glow. In the ring down, the settling vibrations of a newborn black hole, we can test whether space-time truly behaves as promised when it's stretched to near breaking. And by tracing the earliest, faintest mergers, we can ask, were the first heavy black holes born large, or did they grow by feasting in crowded young galaxies? The answers will be written in the statistics of masses and the tilt of spins. Ink too fine for a single event, legible in a library. All of this depends on a deeper kind of craft. Silence is the instrument. Patience is the bow. Engineers will chill mirrors until their atoms barely twitch. They'll suspend them on fibers thinner than a violin string, buried in quiet rock. Far from weather and human footsteps, they will teach light itself to hush, shaping quantum noise so the right kind of uncertainty gets smaller where we need it most. They will cancel Earth's own breathing, the seismic swell, the distant surf, until the ground agrees to act like sky. And still, we leave a chair open for a guest without a name. New octaves tend to reveal new instruments. Perhaps a relic background from the universe's first phase changes. Perhaps tangled strings from primordial fields. Perhaps a family of sources we have not guessed. Because we've never been able to hear this low. Discovery is the art of being ready when the universe improvises. Every new octave births a new kind of story. The triangle in space will give us slow tales, the courtship years before the wedding bell. The giant ears on Earth will give us reach, the same bell heard from farther hills, recorded with finer microphones. Together with our telescopes, the score becomes symphonic. Gravity for rhythm, light for melody, neutrinos for the faint, earthy drone beneath. What do these stories say about reality itself? That time can be measured in music. That distance is a thing you can stretch and squeeze and still trust if you know how to count. That the dark is not empty. It is structured, articulate, generous with clues. We did not make the universe speak, taught ourselves how to listen. The more carefully we listen, the more fluent we become in the language of change. Ahead lies a decade of better ears and kinder silences. Before long, a message will arrive we could not possibly have predicted, and the room will grow as quiet as the day the silence rang. When it does, we will be ready. Eyes tilted to the patch of sky that gravity has pointed out. Hands steady over the controls. Minds open enough to let a new kind of story write itself. Hearing is the first grace. Understanding is the second. Stay with us. The next chapter asks what this music tells us about truth, time, and the fabric that carries every note. These waves are exams the universe sets for our best ideas. It's not written on paper, not proctored by professors. Set instead across 100 million years of empty space, then graded in a single breath. If you listen closely, each chirp is a verdict. On speed, on shape, on the behavior of matter when it forgets it was ever atoms. Stay with me for the next few minutes. We shall read answers the cosmos has already sent. First, the stopwatch test. 2 neutron stars circled, tightened, and finally kissed. So far away their light began the journey when dinosaurs still dreamed. We heard their approach as a rising tremolo in spacetime. And heartbeats later, a flash of high-energy light arrived from the same patch of sky. If gravity ran faster than light, the ripple would have long outraced the firework. If it lagged, it would have trailed by years. Instead, after a voyage longer than life itself, their arrivals were separated by seconds, the kind of delay you get not from the fabric, but from the fireworks. Gravity keeps pace with light. Cosmos uses one speed for signals that matter. Now listen to what happens when 2 dark bodies fuse. The music has 3 acts. A courtship of spirals, a brief shout, and a sigh, the ring down. That final tone is not metaphor, it is a fingerprint. Its pitch and its fading time say something stunningly simple. The remnant is a black hole, described only by mass and spin. No scars, no secret lumps, no hidden hair. When the overtones line up with that spare description, it tells us that Einstein's clean solutions are not just chalkboard elegance. They are instruments the universe actually builds. A black hole duet is a bell made of space-time and its chime fits the score. But before bells, there are tides. Neutron stars are cities the size of a town and the weight of a sun, nuclei with skies. As they draw near, each one raises a bulge on the other, and those tides slightly rewrite the score of the final bars. Softer stars squish more, stiff stars resist. In that hesitation, measured as a whisper of phase, we read the stiffness of matter at densities no lab can bottle. From a single event we infer radii. We rule out the most extravagant recipes for what lives in the core. For the first time, the behavior of quarks and neutrons crushed beyond imagination stops being solely a theory. It becomes something we've heard. When matter is squeezed to its limit, answers in gravity's voice. There is another gift in a waveform: loudness. From the way a signal grows and fades, we can tell how far the source must be. No yardsticks required. Pair that distance with a redshift measured from light or inferred from populations, and you plot a point on the map of the universe's expansion. Do this again and again, and the cosmos reveals how fast its fabric stretches. An independent ruler, checked by no candles, tied to no ladders. A universe can be measured not only by how bright things look, but by how loudly they ring. With each detection, the family portrait sharpens. We learn the masses that are common and the spins that are rare. Some pairs seem born together in quiet neighborhoods, evolving like old couples in a slow waltz. Others look as if they met later in crowded stellar cities, tossed together by chance in a chaotic dance hall. The waves carry accent and attitude, a hint of birthplace. We are not just compiling a catalog, we're learning the social lives of stars. These ripples let us test gravity where it strains, near horizons and in the throats of merging stars. The area of a black hole's horizon should never decrease. In the early data, that promise has held. The speed of gravity should match light. A single event nailed that to exquisite precision. The shape of the ring down should match the pure geometry of mass and spin. So far, the bell behaves. Each check is not a trophy for a theory, but a door into sharper questions. And you can listen. This music is not locked in vaults. Catalogs are public, waveforms are downloadable. Citizen science projects invite your eye and ear. Put on headphones, and you can hear the last seconds of a binary's life. A cosmic heartbeat translated for human senses. If you followed this far, you already speak a little of gravity's language. You belong in this story not as a spectator, but as a reader of the same cosmic script. With more events, the siren map of expansion will clarify, a second measure to compare with the one written in ancient light. With brighter, rarer mergers, we may catch ringdowns whose overtones diverge, hinting at new physics, or at least new precision. With repeated neutron star songs, the recipe for ultra-dense matter will narrow until we can name it like a mineral. These waves are exams the universe sets for our best ideas. And for once, the grading is kind. When we're wrong, the music shows us where. When we're right, it plays the harmony we hoped to hear. Either way, we learn. And now, with the ear trained and the heart tuned, we can turn to the final movement, what all these stories say about reality itself, and how this new sense we've grown will change the way we look up. Press your headphones close. This is not sound carried by air or wire. This is space itself, set to a key we can hear. A long, quiet line, then a soft rise, a quick, bright peak, and a sigh that fades. I've just described the shape of a moment when gravity changed its mind. We did not add music to the cosmos. We translated a pattern your ears already know how to follow. In a few minutes, you'll know how to listen for yourself. What you are hearing begins as strain, a tiny stretch and squeeze of distance, written as a wavering trace of time. Detectors keep that trace with fanatical care. To make it audible, we don't dress it up, we map it. We move the rhythm into the range of human hearing. Keep the shape, the rise, the crest, the fall, because the shape is the story. Sometimes we speed the moment so it fits inside a breath. Sometimes we lower or lift the pitch, like playing the same melody on a cello instead of a flute. It's the same pattern, in a register the nervous system can welcome. Why do this? Because your ears are phenomenal scientists. They detect rhythm in footsteps down a hallway, truth in a friend's voice over a bad connection. Turn gravitational strain into sound, and your brain becomes an instrument. Suddenly, the structure is sensible. A glitch pops out as a click. Merger becomes a vow you can hear. Rising, meeting, letting go. Listen again. First, the approach. A spiral tightening, pitch climbing as two heavy hearts circle faster and closer. Then, the moment. A bright, brief shout when the dance is done. Finally, the after. A fading ring as the new single thing settles into itself. In spiral, merger, ring down, 3 acts, 1 breath. Once your ear recognizes that arc, you will never unhear it. This is not a soundtrack layered on science. It is the science translated openly. We tell you what was shifted, stretched or compressed, the way a map tells you its scale. And because the rules are declared, the music becomes useful. Engineers listen for the hum of the instrument itself, the rustle of seismic whisper, the hiss of quantum light. A human ear catches oddities a graph might hide, a late click, an early stutter, a rhythm that doesn't belong. If you'd like to try, here is a simple path. Step 1. Pick an event, a black hole duet for a clean rising chirp, or a neutron star collision for a longer story. Soft approach, bright middle, echoes of light that follow. Step 2. Map the data. Bring the loudest moment into the sweet spot of hearing. Keep the shape faithful. Let the peak last a heartbeat. Step 3. Listen with intent. First pass, find the rise. Second pass, feel the crest. Third pass, ride the fade and notice what lingers. You can do this. If you can recognize rain before it reaches the window, you already have the skills. Pattern is the oldest language your body speaks. There is room here for many listeners. Archives are open, the waves are shared. With a browser and a simple audio tool, you can see a waveform, then hear it, then share what you found. Citizen projects invite you to spot odd snags in the data, to label shapes, to help separate real sky from local mischief. That work shortens the time from maybe too known. Your careful attention is part of the instrument. And there is culture behind the quiet. These discoveries exist because thousands of people agreed to be still together, to hush the shake of the ground, to tame the murmur of lasers, to respect the stubborn whisper of vacuum. Silence is our instrument. Patience is our amplifier. When you press play on a chirp, you join that discipline for a moment. You borrow their stillness and the universe rewards you with a note. So take a minute, close your eyes. Let a black hole duet cross the room like a bell made of distance. Let a neutron star hymn carry a rumor of gold. We did not make the universe sing. We tuned ourselves to hear it. And now that we can, a last question leans forward. Where will this quiet music take us next? One night, our instruments held their breath, and in that hush, the universe cleared its throat and sang. Not in drum beats or trumpets, but in the softest rise and fall of distance itself. A ripple passed, and two black holes that had danced in darkness for eons announced their vows in a single silver chirp. From that whisper, a choir has grown. Now the night is not silent to us, it is scored. What a privilege it is to live in an age where patience becomes a sense. We learn to still the ground beneath our feet, to calm the light in our lasers, to teach mirrors how to listen. Engineers tuned the world until it could hear its own fabric move. Analysts coaxed signals from seeming static. Communities kept vigil together across oceans and time zones. Wonder arrived and we were ready for it. You are part of that readiness. Every minute you've spent leaning toward the story, you have helped the signal rise above the noise. Your attention is not small. It's a kind of instrument, steadying, clarifying, making room for the note that might otherwise pass unheard. In a cosmos that keeps time, you have chosen to keep time with it. And this is only the beginning of the score. New octaves are opening bass notes that roll for years across a galaxy of pulsars. Murmurs that spaceborne observatories will catch in the long, patient intervals between their mirrors. On Earth, deeper ears are being built to hear farther, earlier, fainter. Each fresh instrument will bring a new species of story. The courtship of massive black holes and young cities of stars. The footfalls of objects skimming the edge of a horizon. The slow tidal sway of the universe's own growth. What do these waves give us, beyond headlines and graphs? They hand us a ruler for the dark, a stethoscope for gravity, a shared rhythm that turns solitary questions into common ground. They remind us that reality is generous. Even the most hidden things announce themselves if we learn how to listen kindly enough, long enough. So let's keep the habit, keep returning to the quiet, keep lending your attention to the patient work that turns rumor into record and wonder into knowledge that lasts. Share the music when you hear it. Make room for someone else to hear it too. The sky will oblige us with more. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, and never stop wondering.